Welcome to today's Rugged Advantage podcast. I'm your host, Karen Hildebrand, and joining me today is Jim Shaw, Crystal Group's Executive Vice President of Engineering. Welcome, Jim.
Thanks, Karen. Thanks for having me.
Absolutely. Always a pleasure. Jim, I think we and our listeners will agree that technology has made us masters of multitasking. We have faster, more portable devices, user-friendly software, and apps for everything from productivity to commerce, communication, and entertainment. And it's all enabled by wireless and cloud-based connectivity. We can accomplish just about anything from almost anywhere at any time. But how does this on-the-go efficiency translate into remote edge scenarios that go well beyond the capabilities of conventional compute devices, since they often require very powerful and highly secure computing solutions?
The thing that we're seeing in the market now is an emphasis on hyper-converged infrastructure platforms. To explain that effectively, you really have to think about a lot of applications that past have been driven by specific hardware configurations to do specific tasks have driven these one-off types of platforms. And so the use of hyper-converged infrastructure really is the consolidation of compute, networking, and storage into kind of generic blocks so that you can spread those blocks and load level across the platform. And what that does for you is it allows your platform to multitask, if you will, and allows you to better optimize the performance that you have available and also make it redundant so that you can create a fail-safe scenario so that given a process that's running, you can actually duplicate that process. And if there is a problem with the hardware, you can fail over. This kind of architecture allows you to use more generic, although all that very capable hardware, but it allows you to kind of commoditize the hardware so that you can in effect, shrink the footprint, improve the swap, and then also make the compute, storage, and networking more generic so that you can have the platform really provide more functions than, say, a application-specific type of a platform might provide. One of the things that does for the military is it allows them to consolidate, reduce the footprint, and that makes it easier to have spares, it makes it easier to transport, it makes it easier to operate. And so that's one of the advantages of hyper-converged infrastructure. And I like your term of multitasking because that's in effect what we're creating is very versatile hardware here that can do a number of functions very effectively, and it becomes cost-effective, lower weight, lower footprint. And so it's all wins for the military and the DoD.
Okay, so when we talk about providing more functionality with less equipment, it sounds like an optimal solution, especially when time and accuracy are really of the essence, and even more so when there may be little or no supporting infrastructure. Now, you mentioned ease of deployment, but can you tell us how else the rugged hyper-converged infrastructure addresses time and accuracy for an overall less is more solution?
Let's back up for a second and talk about the difference between rugged hyper-converged infrastructure and just HCI. And the difference really is it's easy to take a data center computer and make it redundant and put it into a transit case, but it may not last. And so even though we have this failover redundancy, most of our customers require more than just redundancy. They need it to be rugged and redundant. It's one of those cases where you have to be able to use it and it needs to function. Failure is not an option in these forward deployed types of applications where you're running maybe a main operating base or a forward operating base, and you need to consolidate data and essentially protect that data from any kinds of problems that are indicative of being in that kind of tent city environment. When we think about rugged HCI, we're talking about tactical environments and really think about it on a kind of a squad level where you're going in and out of quick reaction force missions or conducting operations in areas of conflict. A lot of these teams don't have kind of IT support or intel capabilities. And so with the growing complexity of some of the intel or the security requirements associated with these kinds of operations, it is nice for the squads to be able to just plug in their system, have it configured, all the key codes are integrated into the system, and security parameters are established, and they can actually download specific information on the region that they're going into, the weather patterns, conflict updates, and then be able to go out on the mission and collect data and then come back and plug back in and extract that information. And hyperconvergence is a capability that allows you to do that. Rugged hyperconvergence really gets that data back to the forward operating base or the main operating base for you to actually execute, transferring that information into a private cloud, a secure cloud type of information where it can be used by various agencies that need that information. The DoD is not unique in that it has these kinds of requirements. You'll see data collection and the security of the data a concern, whether that is power grid or smart grid or whether that is oil and gas exploration. So there's a variety of different industrial applications for this same kind of technology. Again, where Crystal Group really has a play in this is the fact that it's rugged hyperconverged infrastructure, and that's one of the things that makes it a little bit different in terms of the standalone hyperconvergence that you see in the industry today.
That's great, Jim, and I appreciate you making that clarification of rugged when we're having this conversation about the hyperconverged infrastructure and how that plays into the tactical environments, whether they are military or industrial. And I think that's an important distinction to make. Now, with regard to being remote, there are two factors in play: the system being deployed in a remote location and updates being managed from another remote location. So given that there are often significant security concerns relative to cloud computing, especially for top secret and above information for the government and military, can you explain how rugged hyperconverged infrastructure incorporates cloud computing with the assurance of cybersecurity protection?
That's a great question, Karen. The rugged hyperconverged infrastructure really needs to ingest sensor data securely into the cloud while it's really monitoring and allocating where that information goes, who has access. And that's one of the nice things about the HCI environment is that you can actually parse the information, classify it by sensitivity, and then distribute it to the appropriate security enclaves. And so that in itself is a method of making sure that the right data gets to the right security enclaves and you don't put it in the wrong place. And so having that relatively automated in terms of the hyperconverged infrastructure, hardware and software utility, that is a huge benefit. And it's really talking about speed and data assurance. And so these are all good things with respect to the advent of this technology as it becomes more widely used in the DoD or even in, as we said earlier, some of those industrial bases.
Along with that, are there any other layers of security protection in these units as they're deployed?
We do have the ability with some custom hardware that we put together at Crystal Group. We can actually do some sanitization of the data in the event that the platform or the squad comes under, I would say, duress or a situation where they need to abandon hardware. We have perfected an approach to sanitize that data so that we can completely erase the storage and disable the processing so that it no longer functions. In an emergency situation, that becomes an asset in terms of information assurance, making sure that the information doesn't get into the wrong hands.
So it sounds like very solid security, both in the physical presence of the unit as well as that cloud computing level.
Correct. Yes, absolutely.
Very good. So as we bring this wrap session to a close, Jim, what do you think is the most compelling aspect of employing rugged, hyper-converged infrastructure?
To me, Karen, the biggest takeaway with respect to HCI and more specifically rugged hyperconverged infrastructure systems is the fact that we get the opportunity to shrink the footprint of the product while allowing it to do more. So we're really doing, more with less. And that becomes incredibly important when you're loading this equipment in a transit case or on a helo, or you're carrying it on foot. This technology allows you to just shrink that footprint while ensuring the right kind of storage, compute, and networking in a reliable fashion. It really maximizes the overall compute performance in a smaller footprint, but you also get lower total cost of ownership too. So all of these factors come in, and it's really been a significant technology in terms of advancing us into this space for military and industrial markets.
It's outstanding and very well stated. Jim, as always, it's been an absolute pleasure talking with you today. Thank you very much.
Well, thank you, Karen. It's always a pleasure talking to you too.
And thank you to everyone listening in. If you're not already a subscriber, please go to crystalrugged.com/podcast and sign up to have new wrap sessions delivered right to your inbox. And if you have any questions about today's conversation or a topic you'd like us to cover in a future wrap session, just send me a message at info@crystalrugged.com. Until next time, have a great day, and I'll wrap with you soon.